Hi everyone, we are in the video that discuss about the application of integration. First, the subtopic for this application of integration is the area of the region. So to get the area of a region, we can actually apply the integration, okay, to get the area. So here I got one example. Given the AB, given the integrate fx with respect to x from a to b is equal to 10, and integrate the gx from a to b is equal to 6. Find the area of the shaded region. Firstly, you must know that what does it mean by the integrating fx with respect to x. When you integrate the fx with respect to x, actually you are getting the area of this whole thing, this whole region that I shade with the red color line, and which integrate from a to b. B is the lower limit, this is your a, and this is your b, this is upper limit. So when you integrate this is referred to the area of this region, which is red color. I can say that this region is a red region. And what does it mean by integrating this gx from a to b? This is referred to the area which is I shade with the blue line. This is the region. This is a region which is bounded by the curve gx and x-axis from a to b. All right, which is can be written in this form, which I integrate from a to b, integrate the gx with respect to x. All right. So here the question already gives you two answers. One is integrating fx, you got 10. The other one is integrating the gx equals to 6. So now the question is, hope that we can get the answer for this region, which is shaded with the black line here. All right. So how do we get this black line? Very obviously that we can use this big line, big region, minus the region which is I dot. Okay, I dot it. I make a dot here. Okay, which I dot. This is a dotted area. Dotted area is referred to the region of the gx, which I integrate the gx from a to b. So I can use the big area, which is represented by the by this one, 10. The whole region here is 10 units square, and the small region with a dotted, which I call as a dotted region, is equal to 6 units square. So to get the shaded region is equals to, we can say that the area is equals to integrating fx with respect to x from a to b minus integrating the gx with respect to x from the a to b. And this has been given a value of 10 to substitute in, and this is given as a 6. Then finally we got a 4 units square. Okay, so for this question we do not need to do any integration. We just need to understand this is represent which area. All right, and then from the way we from the diagram, we just need to know how do we get the area of the shaded region. All right, so let's look at the question number 2. For the example 2, we need to calculate the area of the region bounded by the curve y equals to x plus 2 and the line x equals to 4, x equals to 6, and the x-axis. So the diagram already given. All this, the sentence here is referred to the region which is shaded with the black line. All right. So want to get this area. This is area under the curve of the x plus 2. To get the area, we just need to integrate from the lower limit 6. Okay, sorry, from the lower limit 4 to 6 is the upper limit, and we integrate the function x plus 2 with respect to x. This, once you have integrated and you substitute the value of the upper limit and lower limit, automatically you will get the area of this shaded region. So just integrate as usual. You get x squared over 2 plus 2x, and then put in your lower limit as is 4 and upper limit as a 6. Then get ready 2 brackets so that you can substitute the upper limit inside. You get 36 over 2 plus 2 multiplied by 6, you get 12, minus, substitute the lower limit and put inside this bracket. you have 16 over 2 plus 4. So simplify it. Simplify, you have 18 plus 12 minus 8 plus 4. Alright? Right, so this is a negative 4, negative 4. And finally, calculate, you got a 18 units square. Proceed to the question 3. Find the area bounded by the curve y equals to 2 minus x squared, which is this line. This curve is representing y equals to 2 minus x squared. And the line x equals to 0, x equals to 1, and y equals to 0. Which this is already done. This is already shaded for you, which the red line is referred to the region that we want to find is area. So to get the area of this region, we just need to integrate from the lower limit 0 to the upper limit 1. And the curve, because this is the region bounded by the curve y equals to 2 minus x squared. So we're going to integrate 2 minus x squared with respect to x. Alright? So integrate as usual, you have a 2x, integrate x squared, you have a x cubed over 3, and put in your lower limit and upper limit. For this, I get ready 2 brackets, so that I can substitute the upper limit in the first bracket. I got 2 minus 1 over 3, and substitute the 0 into this integrated function. I have 0. Then finally, I have 5 over 3 unit square. Okay, it's a square. Okay, this is the area. For the question 4, I got 2 questions here. Find the area enclosed by the y equals to 3 plus x equals to 1, x equals to 3, and x-axis. So without sketching the graph, we can be sure where is the region. So we need the graph. For the question A, this is the graph, y equals to 3 plus x. How do I sketch this graph? Because I just sketch a y equals to x and then move the graph 3 units on upwards. I got 3 plus x. Alright, then after we have the graph, we can try to figure out which region is the question asked for. So the area is enclosed by this curve. And x equals to 1, somewhere here maybe, x equals to 1, x equals to 3, and the x-axis. So basically the area is here. So to get this area, we just integrate, as this area is attached to the x-axis, we just integrate with respect to x, integrate from 1 to 3, and the function is 3 plus x. Just integrate with respect to x. You integrate as usual. You have a 3x plus x squared over 2. And I integrate from 1 to 3. Alright. Then after that, we're going to substitute the upper limit minus lower limit. Substitute 3 inside. You have 9 plus 9 over 2 minus, put in the 1. You have 3 plus 1 over 2. Okay, just calculate and get your final answer. Here we got a 10 unit square. Okay. For the question 4b, I have a quadratic graph here. And the region is bounded by this curve, quadratic curve. And x equals to 0, x equals to 2, x exists. So the most important thing now is to sketch this graph, quadratic curve. To sketch this curve, I need to get its root first, easy for me to sketch. So to get the root, I will make the y equals to 0. Factor out the x, you have x multiplied by x minus 2. Here you have x equals to 0, x equals to 2. This means that you have roots at x equals to 0 and x equals to 2. Where you have this curve at passes through x equals to 0 and x equals to 2. And you know that this is in a quadratic curve and the coefficient of the x squared is positive, means that it will be having this minimum point. You know the shape, having the minimum point. So just draw your curve. Not really perfect, it's okay. Alright, and now you can try to figure out which region they are asking for. You mean you want to get the area region bounded by this curve, x equals to 0, until x equals to 2. So this is the region they asked for. You can see that the region is 4 below the x-axis, so be careful. When you integrate, you will get a negative value. So in order to get the area is always positive, right? So you need to put a modulus sign. Everything, all the operation that you want to do, all will be doing in the modulus. Okay, so you integrate as usual, integrate from 0 to 2, and the function is x squared minus 2x, right? So you integrate with respect to x, and this is in the modulus. Integrate x squared, you got x cubed over 3 minus 2x squared over 2. So we have integrated, and then put in your lower limit, upper limit, and don't forget the modulus sign. The 2 here we can cancel off. And now I prepare the 2 bracket, but the 2 bracket still have to put into the modulus. Okay, then you substitute 2 inside, you have 8 over 3 minus 4. This is the substitution of the upper limit. Minus substitution of the lower limit, you get 0. So finally, you have 8 over 3 minus 4, which produce negative. But don't forget, out here is the modulus sign. You will always make it into positive. Finally, you have a 4 over 3. 4 over 3 unit square. Please stay tuned to my video, and for the next video, I'm going to discuss more questions on the area of a region. See you. Thank you.